Good day, grade 12s. I am just going to be recapping the average gradient and then leading into what we call first principles. The average gradient links directly with first principles, so it's just important that I cover it. And then also these notes I will post up on the Google Classroom because they are the notes that I normally use in class, so they're not the notes that have been posted. All right, so what is average gradient? It's the gradient when we're looking on a curve between 2 points on that curve, and then it's as if we have a gradient of the line that is joining those 2 points on a curve. So if we were to draw now a curve being a parabola, a hyperbola, any sort of curved graph, so we tend to use a parabola. It's common. We want to look what's the gradient between point A and point B. Right, because it's a curve, it has a changing gradient, so we join it and then we look for the gradient of that straight line. Right, so if it's this example here, find the average gradient of a graph f of x equals x squared minus 4. Now remember, f of x is representing a y value in a function for a specific x value. So it says here between the points x equals -1 and x equals 3. So remember your gradient formula from previous years is your y2 minus y1 over x2 minus x1. Your change in y over your change in x. And so we need y values. We've got x values. So let's call this x1 and this x2. Let's find our y values. So we will work with the f of -1, and we place -1 in. Don't forget a bracket here, into our equation that we've been given for our graph, and we end up getting x squared minus 4. So it's 1 minus 4 is -3. And then we work with f of 3 is going to be 3 squared minus 4. So it's 9 minus 4 is 5. So our 2 points that we have, our first point we have -1 and -3, and our second point is going to be 3 and 5. So that's our x1 and our y1, that's our x2 and our y2. So you can work out your gradient between those 2 points. So it's going to be 5 minus my -3, my y values at the top, and my 3 minus my -1. So it's going to become 8 over 4, which is 2. So when you're given the two x values and the function, you substitute them in and get your y values and use your normal gradient formula. Don't get technical. Use your normal gradient formula. So let's look at general situations. So in general, if you have a situation where you have an x value, let's call this one x1, right, at point A, and then you have another second x value, we're calling it x plus h, that's x2, right? So your x1, let's have a look here, your x1 will match up to the graph and give you a corresponding y value. We'll call that y1, which also could be f of x, the function when we have x and you have then a y value that matches it. Then if we look at x plus h, and I'll explain the h in a second, if we match it up to point B that they're looking for and across, that will be our y2 value, or instead of f of x, it will be f of x plus h. Okay, so let's just talk about this h issue. So if we were to actually have values, let's say this is x is 2 and this is x is 5, right? Then if I had these two values, I could put it straight into the equation of this graph and get my y values and work out my average gradient using my normal average gradient formula. Straightforward, straight away. Right, so now let's just have a look here. If I were to look at what's the distance between the point 2 and the point 5, it would be 3 units. Right, so then now we are working with, instead of 2 and 5, we're talking about x and another x point. So instead of 2, we have x1. And instead of 5, we don't know how far we are away. So we know it's our x2, but we don't know that it's 5. So we say it's got to be a certain amount of units away. Now, we don't know how many units because we don't know the actual values. So we say it's h units away. So before it was 2, and then we could add 3 units and get to 5. So now it's x. We don't know where that next point is going to be, so we say we're going to add h units to get to my next one. So it's just called h. It's just a letter that was assigned to it. So h units away. So either way, your x1 point is known as just x. Your x2 point is that x value, and we've gone a certain amount of hops or units away to get to the next x value. So again, if you know both of your x values, you don't need to do anything fancy. Use your normal gradient formula after you found your y values. But here we don't know our two x values. We know one is x and we know one is somewhere else. So it's x plus something, x plus so many units. So we use it in general terms. So it says the general formula for average gradient. That's what this is about, the general formula. All right, so we have your f of x over here, goes with your x1. And then you have your f of x plus h matches your x2. Right, just like we did before, we would have said f of 2 and f of 5, your two x points. So now your x point is f of x is your first one, and f of x plus 8. So that's representing your y value at the first x and your y value at the second x. Right, so it's the same idea. It's just now working with general values. Okay, so let's think, what's our y? I use y1, y2, so y2, y1, x2, x1. Doesn't matter if you use a's or b's. So what is my y value at 2? We said it's f of x plus h, and my y at 1 is just called f of x. And then our x value, our x2 value is called x plus h. And then I'm subtracting my x1 value is just called x. Right, so then at the top we call this f of x plus h minus f of x. And then you'll notice that once we remove this bracket over here, then my x's will cancel and I'm left with just h. Now this is the general formula for average gradient to work out the gradient between any 2 points on any type of function, any curve. All right, so make a little note here. This is between any 2 x values on a graph. It's going to tell you your gradient. So it's a formula that you can study off by heart. That's the formula for average gradient that can be used for any curve. So let's look at this example. Consider the function f of x is equal to 1 minus x squared. And then they've told you for a, determine the f of 2 plus h minus f of 2 over h. Now just remember, this is representing your y2 minus y1 over x2 minus x1. But we only see the h here is because your x's cancel out. So remember, this is the same as saying f of x plus h minus f of x. But instead of the x, they've said 2. So part of this is they have told you that one x value so far is equal to 2, but our x2 value we don't know. All right, we just know it's 2 plus something. It's a certain amount of units away from that first one, from that 2. Okay, so this is the y value at x2. That is the y value at x1. So it's saying to us, please work out the average gradient, because that's what this formula means. The average gradient between x equals 2 and any other x value on the graph. All right, so we want like a general formula so that if we needed to work out the gradient between 2 and 10, 2 and 20, 2 and 1,000,000, any x value, we could work it out using our little formula that we're going to work with. All right, so the first thing you need to do is, I like to do it just on the side. So here's question A. They want us to determine f of 2 plus h minus f of 2 all over h. Okay, again, this was 2 plus h, that's your x2, minus your x1. And so the 2's cancel out. So that's why we don't even have to put them in. We just put our h. It's just about the distance between the points that are important. So on the side, I like to just do it over here. We put in f of 2 because we know what our x value is. We need to find the y value at that point. So we use our formula that they gave us, 1 minus x squared. And so then it becomes 1 minus 2 squared, which is then going to be negative 3. So this is your x1. And so this is going to be your y1 at that point. Then your other x value is 2 plus h. And so we've got to put in 2 plus h where we see an x value. So here you're going to have to FOIL. So it's going to be 1 minus, that's going to become 4, plus it's going to be a 2h and a 2h, which gives you a 4h, plus an h squared. And then we're going to distribute that negative in. So I'm going to get 1 minus 4 minus 4h minus h squared. And once I fix that up, it's going to be negative h squared minus 4h. Some like terms there, minus 3. All right, so now that is representing my y2. So y2 minus y1, x2 minus x1. Okay, so I'm going to just do some highlighting here. So that can be replaced with that. It's the same thing, right? Then this f of 2 can be replaced by negative 3. So that's what we're going to do. So instead of f of 2 plus h, I'm going to put in its representation. And then I'm going to subtract, don't forget to put a bracket here, the negative 3. Okay, so I'm replacing in the formula so I can actually work with actual letters, not just representations of a function y value, all over h. So then at the top, this 3 is going to become positive. So it's going to be negative h squared minus 4h minus 3 plus a 3. So my 3's are going to cancel. And then I'm left with negative h squared minus 4h all over h. At the top, I can take out a common h. And my h's will cancel. And then I'll be left with negative h minus 4. So that is the general that we're trying to get to. So then now for B, it says interpret your answer. So interpreting this answer is saying, what does this h, negative h minus 4 actually mean? It means for B that negative h minus 4 represents the average gradient of f of x equals 1 minus x squared, so that's the graph, the function, between x equals 2 and any other x value on the function. So how would you actually use this? Well, let's say they said, all right, we know x equals 2, that's our x1. So what happens if we want to know the gradient between that x value and x equals 231? So instead of having to put in 231 into the original function, finding the y value, doing your normal gradient, we know the gradient between x equals 2 and x equals anything else is represented by that expression, negative h minus 4. So, what is the distance between x is 2 and x is 231? How many spaces between them? We have 229. So it's saying h, the distance between our x points, is 229. So instead of h, I can put 229, and then I can subs it in and work out that I'm going to have an average gradient of negative 233. Right, so it's an extreme question, but the idea is we have a negative parabola because we have a negative x squared. So between x is 2 and then somewhere else, this graph is continuously going downwards. We're going to have a negative gradient, but because the x value is so far away, it's going to be a really steep negative gradient. Okay, so this extra little bit is just to explain a little bit more as to what you're doing here. You're making a general formula where h is representing the distance between your x value given, x is 2, and any other x value on the graph for all of infinity. Okay, so then now, let's do another one. So consider the function f of x is mapped onto x squared plus x. It's just a different way of writing your function. Determine the average gradient between x is 1 and x is 3. So you've been given both x values, so all you do is you subs it in and get your y values. I'm going to do that quickly for you. Right, so wherever I see an x in the formula, I'm replacing it with the given x values. So there are my 2 points. I can work out my average gradient, which is 5. All right, so then it says now between the points for number 2, negative 1 and f of negative 1. So all this is saying is there's your x1 value. Work out your y1 value by putting the negative 1 into the function. And the same thing here, this is x2 and this is representing your y2 when your x is 4. So you're doing the same thing and then you'll get your gradients using your gradient formula. So there we go. So you just substitute your x's in. So when they've given you x values, subs it in to get your y values, use your regular gradient formula. Right, so what this average gradient is actually leading towards is something called first principles. So if we have a look at our points here, let's think in general. We're not going to use numbers that we know just yet. So we have point A and B. If I want to work out the gradient between point A and B, I can work out the gradient using the straight line that we can join between them. So point A and B, very much like what we had before, is just 2 x values, 2 y values, and we solve for them. So let's say now that I move my point A and my point B. Well, keep my point A. Let me move my point B only. So let's say that point B shifts here. The gradient is going to be different, not as steep. If you look at that one, it's quite steep. The gradient's not as steep. So if I were to move my point B over here, even less. So we're saying now, what happens if I were to move my point closer and closer to A? Eventually, once I move my point B on top of my point A, right on top of it, so B and A on the same point, we actually form a tangent. In other words, a line that just kind of brushes past the graph, touching at point A and technically point B on top of that. All right, so physically imagine moving that point B along the curve. It's going along, it's going along, it's going along, and it's getting closer to A. Eventually, it's on top of it. It becomes what we call a tangent to the graph. So it says now we need to consider what will happen as point B gets closer to point A. The line will eventually become a tangent to F at A. So therefore, the gradient, this is the important bit, the gradient of the tangent at point A is also the gradient of F at point A. So this is working with how to find the gradient at one single point on a graph, because remember the gradient's changing. If you look at the graph, it's quite steep, it's going downwards, negative. Remember, gradient slope. So the slope's going downwards. Then it kind of like evens out, and it starts going upwards, and then it starts getting steep again. Now it's a positive steep gradient. So this is always changing. So we want to know what happens if I just want to know the gradient at one single point. We can look at the gradient of the tangent at that point. Right, so that's very important. So we're not looking between two x values or two y values. We're looking at one set of x and y values. All right, so that's where we're heading to with our first principles. Okay. So the formula for the gradient at a point, it's also sometimes known as the rate of change or the derivative. Derivative is very important here for you to know. The derivative is the word that we use for the gradient at a point or the gradient of a tangent at a point on a graph. We are now going to use a general formula for it and work it out using something called first principles. So you're already familiar with this graph, this diagram. We have two x values, x1. And then the second x value is a certain distance away. We don't know how far it is away. So we say it's h units away. That's the distance away from it. So now we're saying to you, what happens if the h value started off as, let's say, 5? So let's say x1 is at 2 units, and I'm telling you h is 5. 5 hops away. So what will this one be at? It will be 7, because from 2, 5 hops along to get to 7, right? So those are our two x values. But what happens if I start bringing b closer? And so it's no longer at 7. Let's say the new b point is at 4. What's my h then? It's 2. So as I'm moving b closer to a, my h is getting smaller because the distance between the points is getting smaller. So what happens if I were to change my x2 value? I move b even more. Let's say I move b to 3. What's the distance between 2 and 3? It's 1. So I'm getting smaller and smaller and smaller and smaller. What happens if I place b on top of a? So my b value comes all the way down and actually sits on top of a. It means that the x value for the a and the x value for the b are the same value. So is there a difference between them? Are there units between them? No, my h is 0. Right, so h starts to get smaller and smaller and smaller as we bring point b closer to point a to look at just a single point on the graph or a tangent at the graph and not looking between two completely separate points. So it says here, now as b moves towards a, h approaches 0. Very important, h approaches 0. So we can start representing this then as a limit. Remember, if you start approaching, goes towards, it's a limit. So once we get to 0, we have a certain value there. So this is the limit symbol, where it means when h is getting smaller and smaller and smaller, eventually it's going to be 0. And this is to work out your average gradient. That's your general average gradient. So we're looking at the average gradient, but very specifically in a situation that's not random, but where we are trying to get 2 points on top of each other and work out the gradient at a single point on a graph. Right, so this is known as the derivative by first principles. So the symbol that we use for derivative is f dash x. Now please watch out. It's very similar looking to the inverse questions. So the inverse, remember, is f negative 1 of x. That's your inverse. Okay, so don't use that. We want what's called f dash x. Okay, it's like almost like a little apostrophe or a little 1 up in the air. So please highlight or write this out in your notes. This is to find the gradient of a point on a curve, a single point on a curve, or where we draw a tangent at that point, the gradient of that tangent, using something called first principles. The first principles is using the gradient formula that we've learned. So the gradient formula that I did on the previous slides, that's the gradient formula, but specifically when our h is approaching 0. So we bring a limit into the average gradient. That's what's called first principles. So if you're just asked to do average gradient, you don't do the limit part. But if you're asked to do first principles or the gradient at a specific point on the curve or at a tangent at that point, then you're going to start looking at first principles. But the nice thing is, if they want you to use first principles, they tell you to. Right, so you don't ever have to use first principles unless they say first principles. Okay, so that's a big thing. Don't waste time because it's quite a long process to do it. So only do first principles if you're told to. Okay, so again, just to repeat, let's get the correct one. So what's the first principles bit? The first principles bit is finding the derivative, the gradient, at a single point. So specifically this piece is the first principles piece. Remember, using the average gradient general formula that we've looked at. All right, so it says here, we say that this is the derivative represented by f dash x, not f negative 1, f dash x in that formula, and it represents finding from first principles the following. The gradient, or what we call the slope, of a tangent to f at any one point. Remember, tangents can only touch a graph at one point. The gradient of f at any point. The derivative, another word for gradient, of f at any point, so single point, or what we'll pick up later on towards the end of the section is also known as the instantaneous rate of change at f at any point. So more specifically, we're going to talk about rate of change. Okay, so I'm going to do the following examples with you and show you how to set it out, but it's using what you've done with the average gradient, but just putting the limit in as well. Okay, so again, it's a long process. You only do it when they say from first principles. Okay, so we need to find f dash x of this function, so the gradient at a point on this function using first principles. So the first step we're going to work with is we are first going to write out the first principles formula. So f dash x equals the limit of h approaching 0 all together with the fraction, that is going to be over h. It's going to be f of x plus h minus f of x. Those are your two x values. So all you have to do is take from the formula, you're going to do f of x is 1 minus 3x squared, and then I like to do it in different colors. F of x plus h, you're going to subs that in. So it's going to become 1 minus 3, and where I see an x, I'm going to replace it with x plus h all squared. So then you need to FOIL out that bracket, distribute the negative 3 in, and sort it out. So here is the distribution and the fixing up, and that is your representation of your y2. So your y value at an unknown x value somewhere else on the graph. All right, so we are working now with where we see the x plus h, we're putting in our green representation, and where we're seeing our f of x, we're going to put our blue representation. Right, so we still have the limit of h approaches 0 because we can't put that 0 in here because it's going to make our denominator 0. So at the top, you'll always get a way to cancel out everything that's not an h, and then you're able to factorize out an h and cancel it. All right, so my green is 1 minus 3x squared minus 6xh minus 3h squared. And then please be careful, put a bracket here, minus your blue. Okay, because you are subtracting, the f of x, which means you're subtracting a binomial. You need a bracket. So our limit of h tends to 0. Sorry, we don't need a line there. All over h. So now let's fix it up. So our negative is going to distribute in. So we're going to have 1 minus 3x squared minus 6xh minus 3h squared minus 1 plus 3x squared. And again, the beauty of it is anything that doesn't have an h with it does cancel out. So the 1 minus 1, the negative 3x squared, the positive 3x squared. So for your next step, you are left with terms that have h's. Like that. So then, still not quite ready, we're going to take out a common h at the top. Just a single h. I know there's a common 3 there as well, but we don't need to cancel anything else, just that h. Still haven't shown a step without the h though, so I need to first show it. Please keep the bracket, use the bracket there. Now, if I put that 0 in, it's not going to make anything undefined, no maths errors, so I can put the h in with the negative 3, and then we are left with negative 3 times 0 is 0, so just your negative 6x. So what this is meaning is that this is the average gradient at any single point on the curve for any x value at a single point. So if I were to try and just draw a very rough version of what this graph might be, right, and then we pick a single point, let's say over here on the curve, I can work out the gradient at that single point by using my formula here. So let's say they told me the x is 4. So I can put in 4 there, and I know my gradient at that single point is going to be negative 24. But then maybe I'm over here, and I am told that my x is negative 2. So I can say, I know that is my gradient at any point in this graph, but I know now my x is negative 2, so my gradient is positive 12. Or they could have a tangent there. And look how the tangent has got a nice positive gradient, and over here it would have a negative gradient. So this is a general gradient for any one single point on that curve that they've given to us, the 1 minus 3x squared. It's a parabola. And you can find, depending on the x value, the gradient at any single x value on that graph. Right. Here is the next one. This one's a little bit tricky because it has a fraction involved, but it's important to have your knowledge of the fraction. So using first principles to get your derivative, your gradient at a point, we're going to use our derivative symbol and then our first principles notation. F of x plus h minus f of x all over h. So then, again, on the side, my f of x is 1 over x, so that's going to be my blue. And then my f of x plus h is going to be 1 over x plus h. So that's a nice one. So where I see an x, I replace it with x plus h. So that's going to be my red there. So h approaches 0. Can't put the 0 in just yet. So what's my red? My red is 1 over x plus h minus my blue is 1 over x. So now at the top, we have a problem. We have a fraction minus a fraction. We need an LCD. So our limit of h tends to 0 all over h. Our LCD at the top, hopefully you agree, is x into x plus h, one of each of them. So this needs the x multiplied to it, so that's going to become x, and then this needs the x plus h multiplied top and bottom. So it's going to be minus x plus h. Just to make it look a little bit neater, I'm going to bring the h out and just say divide by h, because if it's a denominator, it's dividing. So then my top is going to become x minus an h. So we're just going to have our negative h over x into x plus h divided by our h. So let's just move that up a bit. There we go. That goes there. Okay, remember, when you have an h, it's actually an h over 1. So we can tip in times, and it becomes 1 over h. Everything else stays the same. We still can't put our limit in yet. But here my h's cancel, and I'm left with the limit of h tends to 0 of negative 1 over x into x plus h. Now, I know some of you freak out. You see suddenly there's still an h in the denominator. It's fine. When you put the 0 in, it's not going to make the entire denominator 0. That's the only time you've got to worry about it. So, if I were to now use the limit, and I would say 1, negative 1, and then put that 0 in there. All it means is I have negative 1 over x times x, which is negative 1 over x squared. And that's the answer. That's saying if you want to work out the gradient at any one single point on this is a hyperbola, because it's got an x in the denominator, then you are going to use the x value at a certain point into this formula, and it's going to give you the gradient at any one of those points. Okay, then the last one. The last one's quite quick. It is, they said f of x is equal to 3. So this is talking about y equals 3. It's a constant graph. So there's 1, 2, 3. So it's saying we have a line at y equals 3. What is its gradient? Its gradient is 0. There's no rise, there's no run. Remember, a straight horizontal line's gradient is 0. And if it was vertical, it would be undefined. So you still have to put in all the first principles, because that's what the question's saying, by first principles. F of x plus h minus f of x all over h. And then you are going to put in the f of, well, let's do it on the side here again. So f of x is 3. Now, f of x plus h is still going to be 3, because it doesn't matter what the x value is, the y is going to always stay 3, and there's no x to subs in. So you actually end up having the limit of 3 minus 3 all over h. So you end up with the limit of h tends to 0 of 0 over h. Now, we don't even worry about that h. Straight away, our f dash x is equal to 0, because our numerator is 0. Okay, so whenever you have a constant, the gradient of a constant graph is 0. Gradient of a constant. Gradient means rise over run. The change, it's going upwards. So remember this from like grade 7, grade 8, going into grade 9, your rise over run. It doesn't have a rise, it's just got a run, it just goes across. Okay, grade 12s, I know this was quite long, but it's covered the different types, and hopefully you understand the first principles, and then the second video is just going to go over the notes that were posted on Google Classroom.